Hi, welcome to Capulin Volcano National Monument. I'm Ranger Bernie, and I'm here with Ranger Melissa, Ranger Rachel, Ranger Melanie, and Ranger Jeff, and we're about to take you on a virtual hike of the lava flow trail here at Capulin Volcano National Monument. The lava flow trail is a 1-mile loop. It's easy to moderate. Most people that we hike with on the trail find they can accomplish it fairly easily. It's a good idea to bring some water and certainly some sunscreen. Along this virtual hike, we're going to talk about some of the plants along the trail. We're going to talk about some of the rocks that you're going to see along the trail. And we're going to talk about some of the people who lived in the area and what they did. Now, and back over my shoulder, you can see a part of Capulin Volcano. Capulin Volcano is a 60,000-year-old cinder cone. And one of the things we're going to talk about on this hike is how we figured out how old the volcano was. I hope that sounds like fun to you. It sure does to me. Let's get started.
Hello, everyone. I'm Ranger Melissa. Behind me, you can see the cinder cone of Capulin Volcano National Monument. If you look closely, you'll notice on the right side of the cinder cone over here, it's a lot steeper than it is on the left side of the cinder cone. The left side has a lot gentler slope because the left side is where a lot of the lava from Capulin Volcano was actually produced. Not all of the lava erupted from the top of the volcano. Most of it erupted from this left side area with the gentler slope in an area that we call the Boca. Those lava flows covered about 16 square miles of the surrounding landscape. We're actually standing on one of the lava flows right now, and we'll be continuing to follow it on the rest of our tour.
Here we are standing in front of one of the most dramatic examples of the lava flows that came out of Capulin Volcano right in back of me. We call this a levee, and what it really is it's a more viscous part of the lava flow that came out of Capulin Volcano. And what I mean by viscous is it's thicker and more lumpy, kind of like when you make your morning oatmeal and it clumps together. That's what you see in back of us, is lava that was all clumped together and kind of sticky. But we're actually standing on part of the lava flow. That is a less viscous, more thin, runny part of your breakfast oatmeal, where it just runs real easily. The reason why you don't see that lava flow beneath us is because, remember, this happened 60,000 years ago. And in the time since then, the wind has blown all kinds of dust, all kinds of plants have grown up on that dust, have died, added its organic material to the soil, and it's covered up that real thin part of the lava flow. If you go up our road to the top of the volcano and you look out on the southeast side, you'll see the rest of this lava flow stretching out across the plain. It's like somebody spilled their bowl of oatmeal. It's a wonderful, interesting sight to see.
As you're hiking along the lava flow trail, you might notice several of these large round bulges of volcanic rock. These bulges are known as Squeezeups, or the fancy Latin term for them is tumuli. These tumuli will form when you have lava flowing over the landscape. As soon as that lava flowing over the landscape is exposed to air, it starts to harden slowly. Eventually, you get a hardened crust on top while the molten lava is flowing underneath. Occasionally, the molten lava flowing underneath that hardened crust will be too much for the hardened crust to contain, and it'll squeeze up and crack that hardened crust, forming bubbles of molten lava that harden on the top. Eventually you have more bubbles of molten lava and more bubbles of molten lava and more bubbles of molten lava, and eventually you have this large squeeze-up. Now, not all squeeze-ups are large like this. A lot are pretty small. It just depends on how often that molten lava bubbled up through that crack in the hardened crust of a lava flow.
I'm sitting on one of the rocks that you find on the lava flow trail right here near Capulin Volcano. And one of the reasons that I wanted to sit here and show you something is I find this light-colored material on the rocks to my right just fascinating. It's what we're looking at here is a light green material, and it is called lichen. And lichen is a symbiotic organism. In other words, it's two organisms working together to survive. One of the organisms is always going to be a fungus. The other organism is either going to be a cyanobacteria or an algae. And what the fungus does is it supplies moisture and shelter to its companion organism, and either the algae or the cyanobacteria supplies carbohydrates to the fungus. But the real reason why I wanted to point this out is that when volcanoes erupt, the landscape after the eruption will usually look like a moonscape. Nothing's growing there. It's all dark and dusty and dirty, and you don't see any green at all. Usually, the first sign of life that you see is going to be lichen. And the reason why lichen is significant is because it's the first sign of life, and it literally builds up the conditions for more life to come after the eruption of the volcano. And it'll do that in two different ways. Lichen will break down the rock and form soil. But the other thing is, each generation of lichen dies, the organic material from that dead lichen will fall into the soil and create more nutrients for new plants to grow.
Behind me, you see Sierra Grande, a volcano about 10 miles to the southeast of Capulin. Capulin is not the only volcano in this area of northeastern New Mexico. It's actually part of the Raton-Clayton volcanic field, which stretches about 8,000 square miles in northeastern New Mexico, southeastern Colorado, and the panhandle of Oklahoma. There's a lot of volcanoes in this area, and there's been volcanic activity here for about 9 million years. Sierra Grande is probably one of the most impressive volcanoes in the volcanic field, besides, of course, Capulin. Sierra Grande erupted about 2 million years ago. If you look at its gently sloping sides, it looks kind of like the classic shield volcano would have. But it's actually a pretty large volcano, and if you were to go a little bit closer, those sides are pretty steep. It also erupted a rock called andesite. It's actually the only volcano in the Raton-Clayton volcanic field that did erupt andesite. Most of the volcanic rock that Capulin produced was this kind of grayish black lava rock you see around us, which is basalt, kind of the classic lava rock.
All right, I'm standing next to this line of rocks here on the lava flow trail because I want to talk about something that I actually mentioned right at the beginning of our hike. I mentioned that Capulin Volcano behind me here is about 60,000 years old, and you're going to wonder, well, how do they know that? Because it seems fairly clear that man was not around here, so we have no historical record of Capulin Volcano erupting. Well, here's how they figured it out. They did it in two different ways, and they didn't figure this out until the late 1990s. The first way is geologists took samples of these rocks, and they are able to precisely measure how long these rocks have been exposed to the rays of the sun. And that measurement came up with a dating range of about between 55,000 and 65,000 years ago. And if you're wondering, how can they figure out that the rocks are precisely that old? Remember this, when the rocks come up, when the magma comes up from the volcano, and as it comes out of the fissure of the volcano, it turns into lava, and then it hardens. That's a brand new rock. Just like a brand new car, it's a brand new rock. And so from that point on, scientists can measure how long that rock has been exposed to rays of the sun. The second way that they did it was, and this happened just about a year after they did the first measurement, is these rocks contain an isotope of the element argon. And as you may know, radioactive isotopes, and it's very trace quantities, by the way, radioactive isotopes will decay at a very precise rate that scientists can measure. So by taking samples from the rocks and measuring the rate at which that rare isotope argon has decayed, guess what? They came up with an age range of almost exactly the same age range that they came up with in determining how long the rock had been exposed to the sun. It was about from the mid 50,000s to the mid 60,000s. And it is for that reason that we figure Capulin Volcano is about 60,000 years ago.
As you hike along the lava flow trail, you get a pretty good view of this southern portion of the Raton-Clayton volcanic field, which you see behind me. If you're looking on the far left, you see Palo Blanco, a volcano that is peeking out from behind the round hill of Horseshoe Crater, another cinder cone volcano. Heading further right, you see the Pine Buttes, and then right over my shoulder is Laughlin Peak. Laughlin Peak is a pretty interesting volcano in the Raton-Clayton volcanic field. It's a volcanic dome and is composed of volcanic tuff. Now, volcanic tuff, unlike the name, is actually a very soft volcanic rock, which is why when you look closer at Laughlin Peak, you'll notice deep furrows in the side, which are caused by erosion in that volcanic tuff. Another thing that caused those deep furrows, in addition to erosion, are pyroclastic flows. Pyroclastic flows are combinations of volcanic ash, gas, and other volcanic material that speed down the side of an erupting volcano at speeds of over 60 miles per hour. Pretty impressive. As you head to the left, though, the Pine Buttes right next to Laughlin Peak are also pretty interesting volcanoes. They're over 8 million years old. Now, I mentioned earlier that the Raton-Clayton volcanic field has seen volcanic activity for around 9 million years, which is a pretty long time. In that 9 million years, there's been about 50 to 100 different volcanoes that have erupted in this volcanic field. As you continue along the lava flow trail, you get some pretty interesting views of some pretty old volcanoes.
Hi, I'm Ranger Melanie, and I want to talk to you a little bit about the plant life you'll see while hiking along the lava flow trail. Capulin Volcano exists within a transition zone between the high elevation forests of the Rocky Mountains and the expansive grasslands of the Great Plains. This creates a really unique ecotone that can support a diverse swath of plant and animal life. And you can actually physically see this transition as you move from the prairie, kind of where we're at now, up to the crater. Earlier, you heard Ranger Bernie talk about lichen. Ecologists will often call these pioneer communities. Basically, they help create the conditions necessary for higher trophic level organisms to move in. You can think of ecosystems in terms of a pyramid, with energy producers, like plants, towards the bottom, and energy consumers, like carnivores or herbivores, towards the top. Lichen help to provide a base for our pyramid, and in most terrestrial systems, the next sort of species that will move in are going to be grasses. Here along the lava flow trail, short to medium-sized grasses are going to be what's dominating. This species right here is called blue grama, and it is probably the most ubiquitous grass you're going to see while hiking out here. It's really easily distinguished because of its horizontally suspended seed head, and they look a lot like tiny little paintbrushes. Another sort of grass species you're going to see is this tall one you can see right behind me. This is called big blue stem, or sometimes we call it turkey foot because of its seed head, which branches into 3 parts, kind of like a turkey's foot. It's actually one of the few tall grass species you'll find out here, and it can grow to be over 5 feet depending on the moisture in a given year. A really important quality of both of these species, and pretty much all plant life you'll find here at Capulin, are that they are relatively drought resistant. This is really important for surviving the periods of little to no precipitation that are common across the Great Plains and along the lava flow trail right here.
Hi, I'm Ranger Rachel. So far on this walk, you've heard about the geology and the ecology of Capulin Volcano, but it also has an amazing human history that goes back more than 10,000 years. 10,000 years ago, in these fields back behind me in the plains, you would have seen an animal called Bison antiquus. It looked very similar to the modern day bison we have, but it was much larger. It would have stood about 7.5 feet at the shoulder and weighed more than 3,500 pounds. So these are massive animals. But these massive animals were also a major part of the diet for native peoples living in the area. 10,000 years ago, in an area called Folsom, New Mexico, not far from here, there was a group of hunters and gatherers that were driving bison down a riverbed into an area where they could be blocked off and trapped. And from there, they were slaughtered as the main food source for these people. Once the animals were butchered, they left the bones and moved on to another site. These bones, over time, were covered with dirt, silt, the water washed over them, and they were hidden. In 1908, there was a major flood that came through the Folsom area and exposed those fossils. A man by the name of George McJunkin discovered those fossils and tried to gather interest in them, but they weren't excavated until 1926. At that time, they also discovered the spearheads that were used to kill these bison. They're now called Folsom points, and they were very important to the archaeological history of the United States. At that time, the first man was assumed to be in the United States somewhere in between 2,000 and 4,000 years ago. And those Folsom points set the timeline back to over 10,000 years ago. And discoveries since then have continued to push that timeline back. If you had looked out around here 10,000 years ago, as far as the plant life, you would have seen very similar things. Today, as you're hiking the lava flow trail, you won't see any Bison antiquus, but you might see turkey or mule deer, other wildlife.
Earlier, we talked a little bit about some of the grasses you'll see out here along the lava flow trail. However, it's really the trees of Capulin that start to tell the story of our unique ecotone. You may know that Capulin lies nearby some of the old trail routes of the historic Santa Fe Trail, a trade route that stretches from Missouri to Santa Fe, New Mexico. You can imagine the westbound travelers getting clued into their changing environment because of the appearance of trees they hadn't seen on the grasslands of the Great Plains. Here at Capulin, you're primarily going to see pinyon juniper woodlands, intermixed with some gamble oak shrubs and also some ponderosa pines. This tree right here is a juniper, distinguishable by its scale-like leaves and usually blue, berry-like structures, which are actually its seed cones. Along the lava flow trail, you can see two species of juniper, the one-seed juniper and the Rocky Mountain juniper. They're pretty difficult to tell apart, but the one-seed juniper, as you might guess, typically has only one seed inside of its berries, and those berries tend to be a little bit larger and darker in color than the Rocky Mountain variety. The other major tree you'll see out here is the pinyon pine, which has those distinctive pine needle structures that you're probably already familiar with, and those needles tend to grow in groups of twos. The second half of pinion's scientific name, Pinus edulis, actually means edible in Latin. The nuts produced by the pinyon pine were a valuable food source for many of the native peoples of this area. Additionally, one of the most important ecosystem services that these trees provide for Capulin Volcano has to do with erosion. The steep slopes of the volcano that were formed during the initial eruption were comprised of volcanic material like lava rocks and ash, and slowly, over time, lichens and mosses broke that down into nutrient-rich soil that was hospitable for plants, forming the base of the pyramid we talked a little bit about earlier. The root systems of all plants, but particularly trees like the pinyon and the juniper, help to stabilize the steep slopes and slow erosion caused by wind, water, and human impact. So, beyond just beautifying the area, cleaning the air, serving as a home and a food source for animals, these trees are actually helping to preserve the cinder cone that you can see so clearly out here along the lava flow trail.
If you look at the history books, they'll tell you that the Santa Fe Trail was created in 1821, and there is some truth to that. But the area that became the Santa Fe Trail has been in use for much longer. It was a major trade route in between Native American groups moving between the plains and the pueblos. The Spanish also used pueblo guides that took them out to areas that they knew, trails and landmarks that they recognized, which included areas that became the Santa Fe Trail. In 1821, William Becknell heard that Spain no longer controlled the area around Santa Fe. It had become a Mexican territory. And he was hoping that he would be able to set up trade in the city of Santa Fe. At the time, if it had been under Spanish rule, there was a really good chance he would have been captured and would have been moved into a jail for weeks, months, or even years in the Spanish territory. He was taking a big risk. But the rumors were true, and by the time he got to Santa Fe and sold all of his goods, he had made a huge profit. When he returned to Missouri with the news of this, people started moving west along the trails that he had established. You had thousands of people moving millions of goods over years and years of time. It was used by cattle traders that were moving cattle north to Colorado to sell. It was used by the military to transport goods and to protect the Santa Fe Trail during the Civil War. The Confederates wanted to gain control so they could get the commerce from the Santa Fe Trail. You had people using the trail to move to California for the gold strikes that had been discovered there. This trail that started out on a risk, a whim, ended up being a major area of commerce and expansion for the United States. But everything changes, and in 1880, the railroads reached Santa Fe, and the Santa Fe Trail became obsolete. At least that's what the history books will tell you. If you look at where roads are located today, the roads that we travel, such as the interstate from Raton to Trinidad or 64 from Texas to Raton, you're traveling upon Santa Fe Trail routes. So every time somebody comes to visit Capulin Volcano, or they're just traveling through, they're adding to the history of the Santa Fe Trail.
Hi, I'm Ranger Jeff Goins. I'm Chief of Interpretation here at Capulin Volcano National Monument. And as you saw from my fellow rangers today, Capulin Volcano is more than just a pretty face. It's not just a volcano. We've got incredible human history here, geologic history, and biologic history. And all those factors combined together make Capulin Volcano the unique place that it is. We hope that you've enjoyed this video, but that you can also come here someday and experience the lava flow trail, the Boca Trail, or the Rim Trail yourself, and explore Capulin Volcano and see what a truly outstanding volcanic park it is. Thanks and have a great day.